Welcome to the ONC 2022 Tech Forum Breakout Session, Inferno Framework Capabilities Beyond G10 and Vision for the Future. My name is Jennifer Gilson with Kaufman Associates, and we'll be assisting with the logistical support for this Zoom session. To provide comments or ask questions, please open the chat box, which is located towards the bottom part of your screen. Click on the talk bubble icon, and this will pull up the chat box to the right side of your Zoom interface. We ask that you select the speaker view option located at the top side of your Zoom interface. This will allow you to see the speaker as they present or share information. If you need technical assistance during the session, please type the issue into the chat box and one of our techs will respond to you. Please be aware that today's session is being recorded. The session recordings will be available on the Tech Forum platform within a few days. The recording will be available to view on demand for 1 year, and the slide deck shared in this session will be made available on the Tech Forum platform in the next few weeks. Finally, closed captioning is available by clicking the CC icon at the bottom of your screen. I will now turn it over to Keith Carlson.
Thank you, Jennifer. Yeah, and hello, everyone. This is Keith Carlson. My title is Cybersecurity IT Specialist in the Tools and Testing branch of the ONC Certification and Testing Division. We can just go to the next slide and we'll jump right into this. I guess we do have kind of our usual, someone having trouble hearing me? I just heard in the chat. Is that true for everyone else? Scott, can you hear me okay? Can you confirm really quick? Someone just said in the chat they can't hear me. Okay, thank you, Steve. Sorry, Janice, hopefully you're able to get that worked out. But anyway, just a usual disclaimer for some of these government slide decks is that, any talk of materials based on the provisions in 45 CFR Part 170 and 171, we make every effort to ensure the accuracy of restatements of those provisions. But this is not a legal document, and those, the Code of Federal Regulations is the source of truth. We won't be talking much about ONC regulatory requirements, though, so this probably won't come up too much. But, and then just a second point is that this communication is produced and disseminated at U.S. taxpayer expense. Next slide, please. Yeah, so our agenda for this talk is we're going to kind of start with a Inferno Framework introduction, which if you were at the last breakout session led by my colleague John Bender, Rob Scanlon on that panel gave a little bit of an overview of the Inferno Framework. So there might be a little bit of duplicate information there, but just stick around even if you're hearing duplicate stuff, because I'm going to start to dive deeper into some of those things that Rob Scanlon was giving a high-level overview of. Because after that introduction, we're going to talk more about the Inferno Framework testing paradigms, then give a overview of kind of our future vision for the Inferno Framework. And then lastly, we'll have a live kind of let's build session of getting started, have a walkthrough of getting started writing tests in Inferno. Next slide. So just starting out here with our kind of starting from scratch, Inferno Framework introduction. We can go to the next slide. So, Inferno is a open source FHIR API testing framework that is mainly at this point focused on server and implementation guide testing. It is funded by the Office of the National Coordinator for Health IT, also known as ONC. And it was initially created a few years back to specifically test the, G10 ONC standardized, FHIR standardized API certification criterion. And, when you see the G10 standardized API test kit in Inferno, that is the test kit that specifically tests the ONC standardized API certification criterion. And then the Inferno framework overall so far has been developed and maintained by the MITRE Corporation, through their health FFRDC. And, you can access the reference implementation of Inferno. Kind of our pseudo landing page right now is available at inferno.healthit.gov. And we'll be kind of calling out what more of the components are on that page throughout this presentation. But that's just kind of a place you can start. We can go to the next slide. So this is just kind of a high level diagram. There's kind of a lot of a text here of just kind of calling out the different components of the Inferno framework. I think the main thing I like to get across in showing this slide is just the modularity within the Inferno framework, because we kind of have like a core set of services that are needed just to, run and execute tests and, provide, to take inputs and provide, test results to, as an output. And then, there are different things that kind of plug into those core set of services. And you can kind of modularly build on, different components, right? We see test kits at the top, right? You can have a test kit that inherits tests from another test kit. And so, but I'll just talk through a little bit of these specifically. If we look at the Inferno core section, on the very right-hand side, these are all the kind of services that we consider part of the Inferno core. And we're going to be diving into these more deeply throughout the presentation. So there's the Ruby core domain-specific language. Inferno tests are written in a Ruby Fire domain-specific language. A lot more to come on that. Inferno core includes a test engine, a JSON API, and Inferno core ships with a web user interface out of the box that kind of utilizes that JSON API. You can also create your own web user interface or, utilize that API however you would like, but we provide a web user interface, as well as a command line user interface and a Fire validator. So you have those core services that are needed to run tests, and then different use cases or different communities, or developers building tests will write their tests essentially in what we call test kits. And then these test kits are actually executed by Inferno. And really a test kit can contain a whole bunch, almost theoretically, I guess, an infinite amount of things, right? Because for the G10 test kit, right, we have the test suites, which are, the suite of Ruby domain-specific language code that is executed in the Inferno core. But you can include any number of different things in a test kit that you need for your specific test kit use case. So the G10 test kit is just a good example because, we see listed as in one of those bullets as a reference server, right? For our ONC G10 certification test kit, we provide also a reference server within the Inferno framework that just is basically developed. It's a publicly available server that passes all of the G10 certification requirements. So you can point Inferno at the reference server and just see what a set of passing tests looks like. A reference server would not necessarily be included in all test kits, but it's a G10 specific thing that we like to include, as well as other things like a test data generator. And, like I've mentioned before, the G10 test kit specifically is, all these test kits are modular, right? G10 specifically is made up of a bunch of different test kits. One example is US Core. So, you can pull in another test kit, and like in a community where there's these test kits are being published in an open source way, we would hope that folks can kind of use each other's test kits, and all of the development done by the MITRE team and done currently in the Inferno framework is open source. So we just hope that like you'll be able to maybe use a basic test kit that we provide and pull it in to another test kit if you want to constrain it or add tests to it and add other components to an already developed open source kit. And then, there are just other packages and libraries and extensible utilities that, the sky's the limit for what you can kind of build on top of the Inferno core. So with that, crash course, we can go kind of to the next slide, please. Thank you. So yeah, just go over the two main ways of accessing Inferno. I already pointed out that inferno.healthit.gov link, and that is where we host a reference implementation of Inferno and include, a reference, host a reference implementation of all the, test kits that the MITRE team has developed so far. In this reference implementation, right, is maintained by ONC, and we do our best to, obviously keep it up as much as possible and make sure there's enough, kind of server bandwidth or infrastructure to support folks that want to use Inferno through the publicly available website. And we know that there are a number of folks that do that. But we also, really encourage folks to download Inferno. That was, I think, kind of the original intent a few years ago, was that, the reference implementation was just meant to be a bare bones thing. And we were really kind of providing support for Inferno to be downloadable for folks to run on their own machinery. And also, I think one big use case is to run Inferno behind your own firewall. Because if you're going to kind of point your inferno.healthit.gov at your server that you would like to test, you obviously need to make sure that it's publicly accessible from that website. But you can also download Inferno and run it behind your local firewall, point it at your development environment, and use Inferno, during your development process. Or obviously, you can host Inferno in a public environment too if you want to download it and host your own public version for other folks to use. But those instructions for downloading it are also, available on inferno.healthit.gov, specifically under the, you'll see kind of footers and different links to GitHub throughout that page. And, I know there's a big blue or yellow Learn More button, and there are also instructions there. We'll be talking more about how to download it locally, but you can all find that on inferno.healthit.gov as well. We can go to the next slide, please. So I think we're going to go ahead and launch a poll here, because these are the currently available test kits in the Inferno framework. And I'm not going to read through each of these specifically, and I'll give folks a second to, would love your feedback if you're willing to kind of answer this poll question we have up here. We're just curious if anybody on this call right now has used any of these test kits and utilities that are currently available in Inferno. And I think we're going to give a second for folks to answer. So hopefully that's all popped up, and you can kind of multi-select what you've used, and we'll just provide some helpful data for us of what's being used. I'll just give it a few seconds here before continuing. All right, awesome. Cool. So I see we got those results back. Thank you, Jennifer. Yeah, it's not surprised to see the G10 standardized API test kit up there, and US Core 4. Good to see. Yeah, I wasn't going to do too much live analysis of these results, but these are helpful for us to see, and I appreciate you all responding to that. And we hope to keep supporting as much testing as we can in the future. You'll see that kind of in the ending of this presentation, but we can go to the next slide. And then the one of the last things I want to call out here in this introductory part is specifically make a plug for the Inferno Resource Validator user interface, which is available at inferno.healthit.gov/validator. This is a standalone FHIR resource validator. It's just basically a front end kind of wrapper around the HL7 FHIR validator, but it provides a nice user interface where you can paste FHIR resources and validate them just directly on that on the website. And you can also click advanced options to kind of select different implementation guides or upload different structure definitions if you want to validate a FHIR resource against a specific structure definition. And then, there's a nice interface for providing specific line numbers and highlighting any errors found. We can go to the next slide. So now really want to jump into more of a deep dive. I think this is going to be kind of the meat of at least my section here is talking about the Inferno framework testing paradigms. So let's go to the next slide. So just starting out with an introduction of Inferno's test design approach overall. So I've mentioned the Ruby DSL already, right? The tests within the Inferno framework are written in a FHIR Ruby domain-specific language. We'll see some examples of that coming up. And these tests can be kind of organized and orchestrated into modules, different groups within suites, or, different tests within different test kits. It's made to be as kind of modular as possible, and we provide support for organizing your tests and orchestrating them in an easy way. And there are also some different patterns provided for doing things like generating tests based on structured data. So an example of a structured data artifact in FHIR are FHIR capability statements. I know, for example, the US Core implementation guide provides a really well-defined and really good capability statement that can be used to just kind of automatically generate tests that would test those capabilities defined in a capability statement. And then, Ruby is obviously a full-fledged programming language, and you can utilize that beyond just the Fire domain specific methods. And so if you're writing complicated enough Ruby code, you can do things like test your tests. We can go to the next slide. So now just drilling down a little bit more into the Ruby domain specific language specifically. Some of the things we provide in the Ruby DSL are a, easy instantiation of a Fire client that you can use to start making requests against a server and kind of validating responses. And then we also provide a specific Fire resource / profile validator, just kind of packaged up in this domain specific language. There's also kind of ample room for metadata that you can include within your tests. So as you're writing tests, you can give them titles and descriptions. There's support for Markdown, and there's plenty of room for this throughout the domain specific language, and this information is then provided through the JSON API, and like especially the Inferno the Inferno framework's kind of out of the box user interface that we ship with makes ample use of this metadata to kind of populate the user interface and give context for tests and descriptions of what each test is doing. And then we provide, obviously in a testing environment, you need, the base level pass / fail assertions, but we also provide kind of other flavors of assertions. For example, omit and skip and warnings. I have a whole slide later on just specifically on assertions that we'll kind of drill down into a little bit, because kind of my format here is to give a high level like this, and then now we're going to kind of start to drill down into something, which we'll start with the next slide. We can move to the next slide. So this is kind of the first time you're seeing I'm going to go through similar slides formatted like this. I'm going to go ahead and paste a link in the chat that I would encourage you to save and look at later if you want to see this code on GitHub. That link in the chat goes to a specific file that kind of contains any bit of code that I will be showing on a screen. And, if you want to actually run this code, I'll just encourage you to, on any of those GitHub links, just go to kind of the top level repository and look at the README, where there are simple instructions for how to download Inferno and kind of launch the tests that are included in the repository that I linked. But, here's a specific example of kind of what the code in the Ruby DSL looks like based off of some of the things I've talked about so far. So I'll kind of just follow those numbered boxes on the right here to kind of walk through this. So first, number one, I have an example of how Fire clients are created to make requests, right? This is it right here in the Ruby language, domain specific language. You just say Fire _ client, and then you can pass some different kind of inputs into this Fire client with obviously a URL is required, and there's support for a couple of other optional things you can pass in, like a bearer token if your Fire server is behind an OAuth security layer and you want to provide the token there. You can also provide some headers. But you'll notice that once a Fire client is defined, right, you have a file where you define a Fire client. The block of code below is a example of just a very simple Fire read test within the Ruby DSL, right? We basically nest tests within a test block. That's what tests do, and then end at the bottom is. And then we can put the actual like Ruby methods and Ruby codes that will execute this test or that make up this test in these run blocks. And so number two here, we have a Fire read method that is used to perform Fire read interactions. In this case, we are reading from the server a patient resource with ID 123. And you'll notice here that there's some kind of nice automatic things going on. I didn't have to name the Fire client above. You can do that. We have in our documentation some instructions for if you want to define multiple clients and name them and then use different clients for different requests, you can do that. But in this case, since I didn't name the client, and then in the Fire read, there's no reference to the Fire client above, it's kind of automatically inferred by Inferno within the Inferno framework when you're executing these tests, that you'll just use the client defined previously in the test. So all you have to do here is say just, Fire read patient 123. And then similarly for number three, this last section here, we have Fire specific assertions that we can use to check behavior. And, assert response status is just asserting that the response is HTTP code 200. And then we just assert that this is a valid patient fire resource, which again, I didn't in this example have to name the output from the fire read because it's just inferred that we're asserting on the response from that previous fire read. But again, there's documentation for how you can name these. And I think I'll show an example of that coming up for more specific things. But we can go ahead and go to the next slide, where I will again just paste another link in the chat here to this code on GitHub. But this is building off of, this is just a small extension of the previous example I showed on the last slide. But in this case, we're gonna kind of use the fire resource validator within Ruby. So just some setup, what we're gonna do first, if we look at the top half of the slide, is we're going to read a fire patient from the server. And one of the things I want to do is I want to kind of create 2 test blocks in this scenario. You'll notice in the previous slide that I included all my code in 1 test block, but just to kind of show the modularity here, I'm using 2 different test blocks. And in order to pass the requests between these different test blocks, what I need to do in step number 1 on the right, if we look at number 1 in that top arrow, is I need to declare that this test makes a particular request. So makes underscore request is a syntax to start that. And then I'm going to name the variable that I'm going to use fire underscore patient. Then in the run block, I use a very similar fire read to what I used in the previous slide, but now we're passing in a specific name. I'm saying that I want the response from this fire read to be accessible, via the fire underscore patient name. And then in this test, all I'm doing is just a simple assertion on the resource type. I'm kind of breaking out, modularizing things into, like, in one test, all I want to do is do the read and assertion, and then I'm going to have a separate test for actually doing the resource validation, which is the bottom half of this slide. So the next thing we're going to do in another test is validate that this resource return conforms to the US core patient profile. And in order to use the output from the previous test, step number 4 is, reuse response from previous test. I use this uses underscore request Ruby syntax and name that fire, reference that fire patient variable that I defined above. And then in the run block, I can use the Ruby DSL assert valid resource method and pass in a specific profile URL that I want to validate this resource against, which in this example, I'm using the US core patient profile. One thing I'll note that if you, again, if you go to the GitHub link that I pasted, specifically just be sure to look at the IGs, just literally IGS directory, because that's where I tossed in the US core package, the .tgz package, where these structure definitions are included, right? Because you do need to include the structure definitions for Inferno to look for. But once those are included in the IGs directory, you can just easily validate using code similar to this. We can go to the next slide. Thank you. So really this example is, I just want to show kind of the ample room for metadata that's included within the DSL and how this is rendered on the user interface. And let me go ahead and paste a link to this in the chat where this is included in GitHub, where this example, you'll notice if you're looking closely at the links I'm pasting, I'm just pasting links to different branches within the same repository. And so if you just want to remember that one repository, you'll see all these examples in different branches. But here, we can see, right, for example, at the group level, which I don't think I've shown an example of a group yet, but that's just another higher level way of kind of organizing tests, is you can put them in groups. But at the group level and the test level, we can have titles and descriptions where we can define metadata that can be displayed in a user interface later on. There's support for Markdown. There's kind of a lot of cool things you can do with this documentation, and a lot of nice things that you can have rendered on a user interface. And if you just kind of compare these arrows between these 2 screenshots here, you'll see how something defined in the Ruby code is persisted into the front end user interface. We can go to the next slide. Thank you. So now to go kind of tie things into the assertion results for a second. I know I said I would have another slide talking about the assertion results, and that's what I'll just do here. Pass and fail, again, are self-explanatory. You can, support for a pass means that, or a pass means that Inferno was able to verify correct behavior. But you can also set up tests to fail, which means that Inferno was able to verify incorrect behavior. And then there's also a flavor of skip, which means that Inferno was unable to verify correct or incorrect behavior. And an example of this might be, let's say, for instance, that we have a test where we are validating a fire condition resource, but the server that you are testing does not make any condition resources available. Inferno was not even able to validate the resource in the first place, but the server's not necessarily demonstrating incorrect behavior. So a skip will be, can be, pass through, or a skip can be determined. And, this means that, a skip does not mean that all the tests were passed. It just means that that specific one needs to be looked at again. We also have a omit flavor, which means that Inferno does not need to verify behavior in a specific case. An example of an omit, of when you would use an omit, let's say you're testing an implementation guide that has a requirement saying if a server does A, or if a server does not do A, then it must do B. Then if you have a test that verifies a server does A, then it would not make sense to then verify B, because A is meant to cover that. And so you could say that the test that verifies B is just omitted, and that would show on the UI is just omitted. That was not running. And omitting a test does not mean that the overall test session is a failure. You can still pass with some omits. And then lastly, an error just kind of, or these last two here, an error just covers the case where something unexpected happened and an internal server error is caused. You would need to contact, kind of the test kit author in a scenario like this. And then await is just, what you see while a test is waiting to receive an incoming request, and it will resume once results are received. So we can move to the next slide. And so last little section here, which I see, I want to be able to pass it off here in a few minutes to my colleague Scott, so I might have to go through these a little bit quicker, but just to talk about, and also be sure to stick around because Steve's going to go through this live later. So if this is kind of a whirlwind of stuff, there's still plenty of time to see how this all works again. But the Inferno, just to talk about kind of test orchestration at a high level, tests can be reused within different contexts. An example would be, you can write tests to test a smart app launch and then reuse the same tests for OAuth confidential or public clients, if you're familiar with that kind of OAuth smart app launch domain. And that's what we do for the smart app launch test kit available now. Tests can be referenced and imported between modules. There's support for backend input and output chaining between tests and between test kits. And there also is kind of a support for asking users for input and, kind of providing configurations to the user, and locking configurations also if necessary. So we can go to the next slide. I'll paste this link in chat really quick. Similarly, just another branch of this GitHub repository. This is an example of how you can reference and import tests between modules. In this example, like these two, kind of the upper level block of code and the bottom level block of code are physically in different files. But for example, this top level snippet of code could have tests for, let's say we're testing, again, a patient read. We can ID these tests in some way. And in this example, I've ID'd them as patient_group. And then we can have a bunch of tests, run blocks, however many we want to do. We can define our patient tests in this group. And then we can have another file where we reference this patient group, and the syntax for kind of referencing that group that we ID'd above is shown below. And it's just important to note that these are separate modules, and below what I'm doing is including the patient group defined in the above module. And we can go to the next slide. I will paste the GitHub link again. And, this is an example of how you can ask the user for input. In my previous Fire client examples, I hard coded a URL, but this is how in the Ruby domain specific language you can, if you just use input, kind of this colon URL, or, use this input syntax and then name what the input is, you can kind of prompt the user for an input and then pass that through your tests moving forward. So this is an example of asking the user for a URL and then using that in the Fire client definition. We can go to the next slide. This is just a really simple example of defining inputs and outputs between tests. You know, just for the sake of time, I think I'll move through this quicker, right? Like you can just define, again, and this is all documented in the Inferno Framework documentation. If you go to inferno.healthit.gov and click on the Learn More button, you'll see, I think, this exact example documented. But you can define outputs and then set output values in different tests, and then use, input and output that you defined above in another test, and kind of reuse and reference tests throughout a test suite. We can go to the next slide. This is just to show that outputs that you define in a test in the Inferno out-of-the-box user interface, you can expand tests and you can look specifically for the outputs tab. And, I know an example in the Smart App Launch Test Kit, we provide a lot of outputs when those tests are run. And this is a specific example here of outputting some OAuth artifacts that will be used later on. We can go to the next slide. And then, I've mentioned many times the Inferno different interfaces. We provide an out-of-the-box web user interface, and there is also JSON Swagger API docs that we provide for a, first-class JSON API that you can use if you would like to execute tests through a JSON API. And we can go to the next slide, which is my last slide. So basically, just want to be sure to make a plug for the Inferno template repository, which a lot of my GitHub links that I have been posting in the chat are just, examples that are included in a fork of the Inferno template repository. And there really are, if you look at that most recent link I pasted in the chat, it's a specific anchor to the 4 easy steps you need to get up and running using the Inferno template repository. Just want to be sure folks know that, if you use Docker, it's really easy to get started, and you can kind of get a hands-on view of what all of this looks like. And would just encourage folks to kind of look at that quick start, and, also see how Steve's about to do it live in a few minutes. But for now, I'm going to actually pass it off to my colleague, Scott, who's going to start talking about kind of our future vision building off of this.
Great, thanks, Keith. Hello, this is Scott Bohan from the ONC Certification and Testing Division, Tools and Testing Branch. And in this section, I will cover future goals for the Inferno framework and possibilities for how Inferno may be improved in the future. There will also be opportunities to provide feedback about Inferno through polls throughout this section. Okay, so we can go to the next slide. Thank you. All right, so overall, the future goals of Inferno framework can be organized into 3 categories. First are enhancements to the Inferno framework by updating the technical capabilities of Inferno framework. More accessible and varied testing scenarios can be supported. The second goal is advancement of test kit creation. Test kits, being a distributable collection of tests, are an important structure for testing in Inferno. And this goal is to make the creation of test kits easier through automation and providing examples to use as a reference when writing your own test kits. The third goal is to provide continued support to the testing community by providing resources such as improved documentation, tutorial videos, and informative presentations on testing topics. We can go to the next slide, please. Right, in fulfillment of the first goal of enhancing Inferno framework, many of the user interfaces can be improved. This includes improving existing user interfaces, as well as creating new ways to interface with the Inferno test writing process. First, as shown on the left, existing user interfaces can be improved. For example, the test suite selection screen, where one can select the specific test suite within a test kit, can be expanded to allow for more context about the test suites available to be selected. For instance, the US Core Test Suite could include a brief description about itself and its US Core tests when selected on the menu. Additionally, the test suite landing page, the menu displayed after selecting a test suite, can be improved to allow for more enhanced customization and flexibility. Also, general enhancements to testing interfaces are being considered to provide a smoother testing experience once a test suite is launched. Second, a new Inferno utility is being considered. This utility would provide a graphical user interface to enable easy-to-use test kit creation. The idea here is to provide a utility which makes Inferno test writing easier and more accessible. This utility would help reduce technical knowledge barriers to writing Inferno tests through means such as graphical menus and interfaces to ease the technical aspects of writing code for Inferno. So I'll pause here for our second poll question. And this poll question is asking, what are the barriers to your organization writing test kits using Inferno? I'll pause just for the responses. All right, thank you for your feedback. And I'll just pause here for a few moments so you can view the poll results, and then we'll move on. Okay, I think we can move on to the next slide. Okay, so this slide continues with ideas of how to achieve the first goal of enhancing Inferno Framework. So these ideas include incorporating workflow improvements and expansions to Inferno Framework. Updates to Inferno Framework are being considered, which would enable integration with existing health IT testing tools to enable synergy within the health IT testing ecosystem. For example, this integration would make running other test tools and including their test results into Inferno easier. This integration could be accomplished via a standardized testing API, wherein similar API calls for tasks such as running tests and collecting results would be made across a variety of testing tools. Having a standardized testing API would simplify communication between testing tools and facilitate testing tool integration. Also, support for additional testing workflows is being considered. This includes support for testing clients, such as Smart on Fire apps, increased support for testing combinations of health IT standards, as demonstrated by the G10 criterion test kit, and support for testing via Fire test scripts. And I'll pause here for our third poll question. And this poll question is, how important is Fire test script support in Inferno to you? And I'll wait here so you can respond to the poll question. Okay, thank you for your feedback, and I'll just pause here for a few moments so you can view the poll results before we move on. All right, we can move on to the next slide. So this slide provides considerations for how to achieve the second goal of advancing test kit creation. One major component of this goal is making the creation of test kits easier for the community. Potential avenues to achieve this include improving automatic test kit generation, as well as providing access to reference test kits. For test kit automation, Inferno could be expanded to better support automatically generating test kits and test data given computable artifacts, such as artifacts included in Fire implementation guides. This would ease the burden of writing tests and creating test data, since many aspects of conformance testing could be automatically generated. Second, there are also many existing test kits which can serve as a reference for how to write test kits in Inferno. For example, there are test kits for the Smart App Launch Implementation Guide, the US Core Implementation Guide, as well as the ONC Certification G10 Standardized API Test Kit, which combines many aspects of other Inferno test kits together. The code and instructions to install these test kits are available on GitHub and can be used as a reference when writing your own Inferno test kits. Next slide, please. Here we expand upon the third goal of providing support for the health IT testing community. First, a potential avenue to improve support is improved documentation. This includes content updates to the inferno.healthit.gov homepage to better support navigation to the various components of Inferno. Also, the Inferno Framework webpage can be improved to better articulate information about Inferno Framework and the test kit creation process. This could be accompanied with improvements to the existing supporting technical documentation. Also, this could include expansion of resources on the Inferno training repository on GitHub, which provides a step-by-step tutorial for users interested in writing FHIR tests. Second, more multimedia content is being considered. Video tutorials and demonstrations could supplement the written technical documentation and provide an alternate means and format to learning more about Inferno Framework. Recorded introductions and demonstrations for Inferno are currently available on healthit.gov as well as YouTube. Third is community engagement. Currently, the MITRE Inferno team hosts Inferno Tech Talks for the latest updates regarding Inferno Framework and test kits. Additionally, Inferno testing has been a part of HL7 Connectathon tracks, including the recent September HL7 Connectathon track for ONC certification testing. Additionally, ONC has hosted events to provide support for Inferno, including Inferno office hours and Let's Build sessions. Next slide, please. The Inferno office hours and Let's Build sessions are ways to learn more about Inferno and opportunities to have your questions answered. The Inferno office hours are an open forum for questions on a variety of topics, such as ONC certification testing of FHIR APIs and writing tests in Inferno Framework. They also provide an opportunity to provide your feedback on the Inferno testing experience. Inferno office hours are planned through the end of this year, bi-weekly from 1 to 2 p.m. Eastern Time. Second, the Inferno Let's Build sessions are another opportunity to learn about Inferno. In Inferno Let's Build sessions, topics of how to develop your own standards conformance tests using Inferno Framework are covered. Sessions are planned monthly on the third Wednesday of the month from 1 to 2 p.m. Eastern Time. Registration for the Inferno office hours and Let's Build sessions are available on healthit.gov. And I'll pause here for our final poll question. So this poll question is, were you previously aware of the Inferno office hours and Let's Build sessions? Okay, thank you for the feedback, and I'll pause here for a few moments so you can view the poll results. All right, we can move on to the next slide. And finally, here are some resources to learn more about Inferno. If you want to see how Inferno works firsthand, you can go to inferno.healthit.gov for an online hosted instance of Inferno and for links to other educational resources. Inferno documentation and code repositories can be found on GitHub. The latest news and communications about Inferno can be found on Google Groups and chat.fire.org. Next slide, please. And with that, I will pass to Steve for a demonstration of Inferno Framework.
Hey, I'm Steve. I'm working to share my screen. I'm a lead help IT software developer at MITRE. I'm the tech lead for the Inferno project. So if you ever are wondering, why does Inferno work like this? That seems weird. It's probably my fault. And if you have any technical questions, yeah, reach out on chat.fire.org. We try to be very responsive there. All right, so I have open now the Inferno template repository. And this is sort of the starting place for writing tests in Inferno. There are instructions down here to get started. I'm going to skip over most of these for the sake of time. So here, right, I have the repository already cloned so that I can get started for this. And right, you can run run.sh to build the tests and run Inferno. So I'll just go ahead and do that. So that's starting up. And then I can go to localhost to access Inferno. So here it is. And the template comes with some basic tests to sort of get you started, show you what tests in Inferno look like. And also, there's just that validator UI is also available locally. So you can validate FHIR resources. So if, say, you're an IG developer and you're working on developing a new IG, you can like upload your in-progress IG artifacts to this local validator and right, validate resources. So I just validated the patient resource. No errors, but some warnings and information. You'll see these again when we start looking at doing some actual tests. So, right, a test kit in Inferno is generally designed to test some specific use case, and in FHIR that can often map to a particular implementation guide. For the purposes of this demo, I'm going to write some tests for the US Core 3. I mean, we have US Core 3 tests already, but we also have a reference server so that we can actually make requests and get resources back, which will be helpful for the purposes of this demo. So thinking about writing tests for US Core 3, but first let's just take a look and see what we have in the template, that like the test that just came with it. So there's this capability statement test that we can read a capability statement. Okay, that's good. We want to be able to read a capability statement. And then we also perform a patient read and then validate that resource. And if I look at what's in US Core 4, US Core 3, at the profiles, there's a patient profile. So we can use these patient tests as sort of a scaffold to start building out some US Core specific patient tests. Before we do that, I'll just run all of these tests. So I'm going to use our reference server. And it does require auth, but we have this hard-coded token we can use. And there's a little delay, like before you run the first test. That's just the worker thread that runs the test has to get spin up the first time. And then likewise, you might have noticed another delay. The first time you validate a FHIR resource, the validator has to warm up. So if I were to say, run these again, you can see it's a lot faster the second time, but there was that delay the first time. All right, so they all passed. Patient resources valid, right? It passed. If we look at the messages, right, we see here are those like warning and info messages that we saw when we used the standalone validator. So you still see those, but they're not errors, they're just warnings. So everything passes. Okay, so we want to expand these patient tests. So let's look at that. Another thing I want to do is I don't want to have to type this URL all the time. That is really long and annoying. So let's go look at the Inferno documentation and see how I can avoid doing that. So here is the documentation. If I look at like the table of contents, I'm interested in writing tests. And that's an input. So let's look at inputs and outputs, defining inputs. Right, so you can define an identifier, a title, a description, a type, a default value. Okay, great. Let's use the default value so that I don't have to type in that URL anymore. So here's like this URL input. I can say default. And now next time I should not have to enter that URL, which will save a lot of time in the presentation. So just real quickly, here's like the root of this repo, Inferno template. Lib is where all the tests live. So here inside of lib is where this file is, and this defines the test suite we're writing. I'm not going to bother renaming this stuff right now, but I could. And then there's another folder, and inside there is the patient group. So here's the group with the patient tests. We can like look at them side by side. Right, here's the title with an extra space. Right, for that group, it's patient tests, verify that server, verify, right? So those match. Then there's these two tests, right? Server returns requested patient resource, server returns requested patient resource. So this is the file where these tests are coming from. And one other thing I'm going to do for the purposes of this demo in order to speed things up is we already saw the validation. I'm just going to comment that out and not do it just because we're going to be starting and stopping things a lot. And there's that like delay for the validator to warm up. So I don't want to make you all sit here and just stare at the screen while it waits for the validator to warm up. So we're just not going to do that. So let's go look at US Core patient. And so here's the patient profile information. And down at the bottom, there's sort of this quick start. We can also see here, it's like, see the conformance requirements for the list of supported RESTful interactions for this IG. So let's do that, right? Inferno is designed to test servers API implementations. So we can look at what the servers are required to support. We're particularly interested in patient. So let's scroll down and click on patient. They shall support read. Great, we have a read test. So we have something there at least, and they shall support searching on the type. So we need to be able to perform patient searches. So here are some search parameters. And so here's a shall search, right? So you have to support searching by ID. That seems like an easy test to get started with, right? If we supported read, we had an ID when we read that patient, we should be able to use that same ID to perform a search. And we can look at what's actually done by this read test, right? We perform a read, check that we got a 200 back, assert response status, assert resource type, make sure we got a patient back, and then check that that patient that we got back has the same ID that we asked for. So, right, that's a pretty basic test. We should be able to do something fairly similar for searching. So easiest way to write a new test is to copy an old test and then change some stuff. So that is exactly what I'm going to do. So this I'll rename to something like server supports patient search by ID and verify that supports. You know, these aren't the greatest descriptions or anything, but that's fine. We don't need to have this input here because it was hard to find above. Like, wait, no, never mind. We do need that. This request isn't going to be used by anything else. So I'll get rid of that. So first things we know, we're testing search. So this fire read is going to need to turn into a fire search. So we need to know how to write a fire search in the Ruby DSL. So if we go back here to writing tests, there's a section here on making requests. And I want to make fire requests. So fire clients, yeah. I just want to know how to search. How do I search? Available request methods, fire search. Great, that's what I want to do. For more details, see the fire client API documentation. So I'll click that. So here we're in like the nitty-gritty Ruby documentation. So right, Inferno DSL fire client. So let's look at these methods we have down here: fire client, fire delete, get capability statement, operation, read, fire search. All right, that's what we want. We want to do a search. So fire search takes a resource type. Let's move this over. All right, so this could be fire search. There we have a resource type. It's not going to take just a patient ID like that. And we're not saving this request. I don't need to give this request a name. What I want to know how to do is how to pass in the search parameters I want to use. So resource type, we got client. We don't need a custom client. Params, the search params. Okay, so I can add search params using the params keyword, just like it is up there. So I'll say params. Then I need to know what exactly does this ID search look like, and my Zoom controls are getting in the way. US core. So US core, right? We have this great summary of what an ID search looks like, right? Before we get to patient, and the parameter is _ID. So I'll say _ID, and we want that to be patient ID, right? The input we provided. And I'm going to go ahead and just do some error-based development, right? All I did was change that from a read to a search and change some descriptions. So I'll just run this, see what happens, and fix whatever errors pop up. So I reload, all right, here's this new test. Run them all. And bad resource type received, right? Expected patient but received bundle. Okay, that makes sense. Because here we say assert resource type patient, but if you know how searching works in Fire, you get a bundle back. So we want to make sure that we get a bundle back. So there we go. Assert that we're going to get a bundle. Run this again. Okay, so we managed to bypass that, right? So we got the bundle, but now we're seeing this error: requested resource with this ID, but received one with that ID. And again, that makes sense because we're checking the bundle's ID against the ID of the patient resource. And if we look here at the details of this request, right, here's the body, here's the bundle. It has this big ID, but this bundle contains the patient, and the patient's ID is what we requested, 85, right, which we could see if we go to inputs, patient ID 85. So, right, we were able to, so this assertion just doesn't really make sense. So we just think about what things can I assert about the response to a search by patient ID. And one thing that comes to mind for me is that if I'm searching by ID, there better only be one patient with that ID. So maybe one valuable thing to check is that the bundle that we get back only contains a single patient. So if we look at the base FHIR documentation and look at bundle, right, inside a bundle, there are many entries, and each entry can contain a single resource. So I want to go through the entries and find all of the entries whose resource is a patient. I'm going to check that they're patients because you can get other resources back from a search too. So for instance, a server could return operation outcomes with a search indicating more information about how that search was performed or something about the results. And that doesn't like indicate any sort of error or problem. So we don't want to fail them just because they provide an operation outcome in addition to the patient. So I want to store the patient entries. Whenever you perform some FHIR operation, like a search or a read, the FHIR resource that you get back is just automatically a resource. So I can just say resource, and that will refer to that FHIR resource that we got. And so I want to go through the entries. So resource.entry. And so now we're moving sort of like out of basic Ruby DSL land into some like actual Ruby. So entry, right, is 0 to many. So that'll be an array. So if I look at the Ruby like array documentation, and you can read all these methods. What they do is mostly sensible by their names. We want to select the patients, and there's a method called select. Okay, so I can click on that. Here's how select works, right? You have some array, you call select on it, and then this block, if this block is true, then that thing will be included. If it's false, it won't be included. So I guess entry dot select some entry, then the resource itself is in entry dot resource, and then on that resource we want to check the resource type. We want that to be patient. So right, this should go through the entries, select all the ones that are patients, and right, we should only have one patient entry since we searched by ID, and it would be a problem if a server had multiple patients with the same ID. So let's assert patient entries dot length, right? Length, right? You can also see here in the documentation for just Ruby arrays, right? Length returns the number of elements in self being the array. So right there, we should only find one. If we don't, we could say on multiple patients with the same ID. If you have any questions while I'm going through this, feel free to put them in the chat and I'll try to answer them just as I go along. So I should be able to run all these again. All right, so now it passed. So we have verified that we perform this search and we only find one patient. That's good. But now we also want to check that that patient has the right ID, right? We want to know that we're getting the patient that we are searching for. So we have this array of patient entries. At this point, we know there's only one thing in there. So I could say, patient is patient entries. The first one, I can say dot first. dot resource, right? Because the resource itself is an entry dot resource. So there's the patient. Then we can check that the patient's ID is equal to the one that we input, right? Which is patient underscore ID. And if that isn't the case, we'd say, you know, expected to find patient with ID. That's the one we expect, but found that. So now we should do a test that actually, right, gets them all, checks that we only get one, and then checks that the ID is correct. This says it's good. It's hard to really know, right? We haven't seen this fail because this server is behaving properly. It would be useful to see it fail. So I'll just say patient ID equals XYZ. And if we run these tests again now, we should see that test fail because the those IDs won't match anymore. And we see that, right? Expected to find patient with ID XYZ, but found 85. Okay, so that seems to be a working test. So great. So we have a test for this one search that's a shall. And now I think we could move on to a more complicated example. If we look down here, there are some search parameter combinations. So we could do, say, search by birth date plus family. Family is family name. And this is a should requirement. So it's not required that servers support this. So we can go ahead and try and write a test for this. And once again, easiest thing to do when you're going to write a new test is copy an old test. So I'll copy this old test. We want the server to support patient search by birth date plus family. Okay. So we're not searching by patient ID anymore. So we don't need a patient ID input in this test. We need a birth date input and a family input. And then this search, right, we're not going to be searching by ID. And again, we can look at the US core documentation and see what this search looks like, right? Birth date is just birth date, all lowercase, and family is just family, all lowercase. So you can say birth date, birth underscore date, right? Using underscores to separate things. It's just the normal Ruby way of doing things. So I will be doing that where possible, but you'll see other things where Fire differs, right? So Fire says this is birth date with no underscore. And, you know, then you'll see like on the patient resource itself, it's birth date with a capital D. So yeah, there'll be some different capitalization schemes going on. Okay, so if we're searching by birth date and family name, this check that there's only one isn't going to work, right? Nor will this thing saying that, oh, we expect this ID. So for now, I'll just comment these out. And I'm going to make sure that I can run this basic test, right? Checking for a birth date and a family name. And then we get a 200 back and we get a bundle back. All right, so here we see the new test. And here we have inputs. So birth date, say 2000, something really easy, family name. I'll go ahead and use mine. Okay, so that succeeded. Let's take a look at this request. Well, they didn't find anyone with that birth date and family name, so this is an empty bundle. But all we checked is that we got a bundle back and we got a 200 status, and we got those, so passed. But, you know, that's not a very useful test. We probably want to check things like, you know, do the resources we get back match the things that we searched for? But in order to do that, we need to know what are like family name and birth date combinations where we can actually find a patient like that on the server. And well, that's annoying, right? Like, if it's your data, yeah, that's something you could memorize, but you probably don't want to memorize that and then have to input it every time you run the tests. So instead, if we look at the patient we got back from the read interaction, right, ID, meta text, a bunch of extensions, identifiers, right, here's their name, and there's a family name. Okay, so that patient has a family name. So it would be great if we could use that family name. And then similarly, that patient has a birth date. So let's set it up so that this new test performs a search using the birth date and the family name from that patient that we initially found. So to do that, we can go up to this read test and we can add some outputs, right? Currently it just has inputs, and yeah, it saves this request and gives it a name. But we can also add some outputs, right? We want to output birth date and family name. I should show this in the documentation. Zoom's torturing me. So writing tests here, test inputs and outputs, right? We looked at this before for defining like additional properties on inputs. If we go down to outputs, it's pretty basic. You say output and you provide one or more symbols that says, hey, this test is going to have these outputs. And then within the run block, you can, you know, call output and use those symbols as keys and then give the values you want to output to those. And then those outputs are available for other tests to use. So there I defined a birth date and family. Now I want to output right, birth date, that will be in resource, right? We performed a read here, so whatever resource we get back is automatically in resource dot birth date. And then for family, this is a little more annoying because if we look at name, right, patient.name, that's one to many, so that's going to be an array. And if we look at the patient we got back, right here, yeah, we can see, right, this is in fact an array. So to keep things simple, I am just going to say, just grab the first name on there and get family from that. So, right, that will populate the birth date and the family name based on these outputs or based on this patient. And these inputs down here, birth date and family, they have the same name. As far as the server is concerned, they are the exact same thing. So it will automatically use those outputs to give the value for these inputs. If you want to know more details about how that works on inputs and outputs, there's this little behind the scenes section that explains like what is going on with inputs and outputs really. The one sentence explanation is it's a global key value store. Okay, so here we are back here. Right, so if I click run on this search by birth date plus family, here you can see the birth date and family inputs with those values that I provided before. But if I click run all tests, oh, I need to reload this. If I click run all tests, you don't see those inputs anymore. Okay, I'll show you after I reload, right? You still see them here. If I try to run that one test, but if I try to run this whole group, you don't see those inputs anymore because Inferno has realized that this test has some inputs, but those inputs are supplied by outputs in this earlier test. So you're not going to be asked to provide those values. Even if you did provide those values, they would be overwritten when this test wrote its outputs. So there's no real point in asking you for them. But here, if for some reason you wanted to specifically use a special birth date and family set of parameters that you define yourself, you could just run this test on its own to do that. We do also provide a way to force you to like run tests at this group level rather than at the individual test level. And we use that like in the G10 test kit for some of the more complicated things we have to do. But okay, so I should be able to run all these tests. Hopefully they will still pass, and we will see in this one that we perform a search using the birth date and family from this. So I can look here at this test, look at its outputs, right? Birth date and family. If I look here at its inputs, there's the birth date and the family, and in the request, well, it's in that little tooltip. If you can read that, that is the right birth date and the right family name. And if we look down here, hey, we have a result now, right? We're not just getting an empty bundle. We got an actual result. So that is great. And now we still probably want to check that the results we got like match our search parameters. I mean, the fire spec is pretty loosey-goosey about this in terms of whether search results have to match your parameters. But for the sake of this, let's say that your results have to match the parameters. Once again, we're going to want to only look at the patient entries, right? A bundle could have a bunch of other stuff in it, like operation outcomes, but we don't want to look at those. We just want to look at patient entries. So we can use this same line of code I copied from above to go through the bundle, pick out the patient entries. And right, we could have multiple patient entries now. So we're going to want to check that all of them match our search parameters. So birth date is the easiest one. So if we want to check that all of these patient entries have that birth date, right, we're going to have to go iterate over the array and check all of them. Luckily, Ruby gives you an easy way to do this. Right, in Ruby, like methods that return true or false have a question mark at the end. So it's an easy way to find if, say, you are wanting to see methods that tell you true or false about something. So in this case, for an array, we want to know, is this true for all of the things in this array? And there's this handy dandy all question mark method. So you can ask .all, pass a block, and if that is true for all of them, you get a true back. Otherwise, you get false. So we can use that to make an assertion. So let's say like correct birth dates right? We're going to patient entries all entry. And then again, we have to go to the entry.resource to get the resource itself. Entry.resource, we want to check birth date. We want to make sure that that is equal to the birth date input, the thing that we searched for. So I can just assert correct birth dates, and that's it, right? Because this method returns a true or false in the same way that like this comparison would return a true or false. So I can just assert on this variable, like rather than like doing a comparison in the assertion itself. And if that fails, I'd say, you know, not all patients had the correct birth date. So rerun the tests. And they should still pass. And they still pass. Great. So we've checked that they all had the right birth date. Now we need to all check that they have the right family name, right? And that's going to be more complicated because a patient can have multiple names and only one of those names needs to use that family name. So, right, we have to check them all. So it'll start similarly to the last one, right? It's like correct family name, patient entries dot all. This is going to take up more than one line. So I'll use a do instead of curly braces. That's just like a thing I'm blanking on, convention. So this entry dot resource has many names, and we want to check that, you know, at least one of those names has the right family name. And right here below all is this method any. So we can use this any method to check, hey, in this list of things, is this true for at least one of them? So that's how we can check over this array, you know, in this, you know, more complicated like nesting loop kind of thing. Entry.resource.name, right? Got many names, .any name dot family is equal to family. I'm also glossing over the complexities around string comparisons in search in Fire, but there are some dragons there to be aware of. So let's assert correct family name. And if that's false, we'll say not all patients had the correct family name. And it should still pass. It does. For a sanity check, let's do something we know will fail to see it fail. So now we're going to check that the family name is equal to the family name plus XYZ. That should not be the case. So this should now fail. And it fails, right? Not all patients had the correct family name. But now there's another thing to fix. If we go back to the US core requirements, what are servers required to support for patients? They're not required to support birth date plus family. So it's okay if this doesn't work, right? It's a should. So it's still a good idea to check, but we shouldn't necessarily fail them, you know, if they don't do it right, because they don't have to support it. So the way that we can handle that, if we go back to the documentation and look at test properties, there's this one optional / required. So we can mark a test or an entire group as optional, and we'll still evaluate whether it passes or fails. But if it does fail, it won't make like its group fail, right? That failure won't cascade up. So in order to do that, we just say optional inside the test. So say optional. Rerun it. And like changing it from required to optional does like mess with some things. So I am going to just start a new testing session for this. Still using the same values for everything. So now we see, right, this optional test failed, right? It's no longer a red X, it's a gray X because it's optional. And this group still counts as passing. So you can do this, you can use optional tests to check non-required parts of an IG. People might still want to support these optional things and are interested in knowing that they do it correctly. But, if they don't do them, they can still be conformant to the IG. And okay, so I should get rid of that thing that made it fail so that there's a, we're in like an actual good state, not this weird state. Let's see, I'll need to reload this UI to make that not appear as optional anymore. Oh no, never. No, I don't. It's still optional. It's just not going to fail now when we run it. Hey, it passed, right? So yeah, an optional pass gets that light green check mark. So this is sort of the basics of how you can sort of get started writing tests in Inferno. But something to keep in mind is that before I started actually writing the tests, the first thing I did was look at the IG and the requirements and figure out, what is something I can test, right? What's it going to mean for a server to be conformant to this IG, right? And then involved like looking at these conformance requirements saying, oh, you shall support this, so I can write some mandatory tests for this, and you should support that, so I can write some optional tests for that. So yeah, that concludes this demo. I don't know if we have time for questions or anything. Maybe one if someone has a question. Otherwise, yeah, chat.fire.org, the Inferno stream, the Inferno team hangs out there. And we try to be very responsive when people have questions.
Well, thank y'all very much. All of the session recordings will be available on the Tech Forum platform within a few days. The recordings will be available to view on demand for 1 year, and the slide deck shared in the sessions will be available on the Tech Forum platform in the next few weeks. Thank you for attending the 2022 ONC Tech Forum, and have a great rest of your day. Thank you, everyone.